everyone, welcome to the second video in the Anomaly Drones Stryder video series. This will be the build video, and I'll start off here with some of the things I'm going to use to build this guy up. This is going to be a ProSight machine. The machine was designed to use the ProSight, and so that is the video system that will be going into here, including the transmitter, which you guys have seen before if you watched the build video I did on the Dragon previously. And of course we'll be using the stock antenna, which I find has the best range. I've tried a few different combinations and I still keep coming back to this stock antenna. I know it's a little bit more fragile than the new racing antenna that's coming out, and it's more fragile than some of the other configurations that people have been coming up with, putting the antennas in a V and such. And even the Dragon used the V configuration, and I found that the reduction in range was slight but there. And for my type of flying, I like to have the best signal possible. And I don't do a lot of racing personally, so I don't tend to destroy these all that much. I've broken a couple of these, but you know, I've broken a couple of analog antennas too, so I don't think it's that big a deal. And I like having the really solid signal that this gives. I do use a little bit of electrical tape. If you look here, I wrap the end here with electrical tape. That helps to protect that wire, which can scrape on the ground if you land upside down, and kind of abrade through the outer coax there, which causes problems. So a little bit of tape there helps out with that. I'll be using my trusty KISS suite, which means I'll have the KISS flight controller that you see here, and this one's kind of, I've pre-wired this a little bit with a buzzer, power wires, and the receiver wires, and tinned all the pads for the ESCs. And I'll be using the KISS ESCs. This is my XSR receiver. I always use either an XSR or an X4R SB. Some people prefer the X4R because they have replaceable antennas and these are solder on, but I don't really have a problem breaking these antennas. I guess if you protect them pretty well when you do your build, they tend to last a pretty long time. I haven't really had problems with it, but I'm pretty averse to crashing, so I don't crash all that much. Maybe once every few flights or something, I hope. So I haven't had too much bad luck with these XSR receivers, but if you prefer to have the ones that have the little U.FL connectors on them, you can use the X4R. And this is the PDB that I'll be using. It's the Luminaire PDB. It's very simple, and we don't even need to put the voltage regulator on there because our flight controller can run right off the battery, and our ProSight transmitter can run right off the battery, so we don't need any extra voltage regulators or anything. It makes things very simple. And on this build, I'm going to try these 645 HQ props. This frame can handle a 6-inch prop, and so I'm going to give it a shot with these Cobra motors. Now these are not the Cobra Champion motors. These are the older race motors. This is the 2206 2100 kV Racing Edition, and you know, by today's standards this is like a slump, right? But the lower kV will work well with the high pitch 6-inch props, and it will keep the thrust values still quite high and have a reasonable current consumption, because I'm hoping to fly this machine for 5 minutes or so, maybe even more on some freestyle flying, and really get some top speed to go with it. So with a 4.5-inch pitch, we should have a good combination of efficiency and speed, and the lower kV motor will help with that. And these motors are still quite powerful, so I'm going to give them a shot and see how they work out. Okay, so one of the first things you want to do when you get a new frame is chamfer the edges wherever needed. And these frames are supplied without sharp edges. They're not chamfered per se, but they're not really sharp. It's not really something you have to worry about on the general frame itself. But we do have wires that are going to be passing through the frame here. Remember, we've got these nice little cowlings that go underneath for our ESCs, and so the motor wires come down and they go to the ESCs, and then all the rest of the wires go up through this hole and go to the power and flight controller. So I've gone through and I've chamfered those holes with a countersink tool all the way around the frame. There's 8 of those holes, and I've just gone around and chamfered each one of those top and bottom just to prevent the wires from getting damaged as they scrape, you know, as vibration causes them to rub slightly along those things. So now the first thing we're going to do is, you see I've mounted up a motor and I've put a piece of tape on there. What's the tape for? Well, what I did was, and this is the recommendation of the Anomaly Drones folks, is to drop the ESC into the cowling and put it up under the frame where it mounts and see where the edge is. And I just marked that edge with a piece of tape. So that's going to help me figure out how long the motor wires are. And the tip that was given to me was that the distance from the motor wire hole to the edge of the ESC is approximately the width of the ESC. But I think that may hold true for the smaller ESCs. These ESCs are very wide. So that would put the ESC way back from where the tape line is. And the ESC is actually going to be, you know, right about there, right in line with that tape. And so I'm going to use the tape method to tell me how long to make the motor wires. And so what I need to do next is just hold the ESCs in position here, or maybe tape them in place and cut the motor wires to length. Okay, so what I did here was I just held the ESC underneath the arm like this, just kind of by hand. I just held it like this, and I took my handy little wire clippers and I just clipped each of the wires to the right length and said, okay, they're going to be coming in at an angle, and tinned everything and soldered it like you see here, and it's just kind of flapping in the wind right now, but you can see that when I put the cowling on, it's going to line up with that piece of tape that I have up there pretty well. I left a skosh of extra wire on there because I just hate cutting things too short. No matter how many times you cut it, it's still too short, right? You ever heard that? It's true. So I think I'm good to go here. If I line this cowling up, it seems to slip right in there just fine. Of course, I've got the screw head sticking out, so I can't make it completely flush right now, but you can see the ESC is going to fit in there just fine. The wire length seems to be just about right. Having a little bit of extra wire length is not hurting me here, so lining this up with the cowling seems to be pretty easy. So that method was pretty quick and simple. That only took me about 5 minutes, so I think I'm going to do the other 4 the same way with each of the motors and, you know, a piece of tape to mark the ESC. Okay, all my ESC motor wires are soldered in place, and so the ESCs are sort of hanging in space where they'll end up. And I just wanted to mention a few things I learned along the way here. One is I didn't really pay attention to what orientation the ESC was in. Some are facing front, some are facing back, some are up, some are down. It doesn't really matter because at least with the KISS ESCs there is a reversing pad that you can solder together there. There's 2 little pads that you can solder together right there that will reverse any of the motors. So these ESCs have been used in another model before, so I just went ahead and unsoldered all 4, and then once I get this thing all put together and I do the smoke test and make sure everything is good and I'll see what orientation the motors are in, which ones are spinning backwards, I'll come back and just solder the necessary jumpers on the necessary ESCs to get the motors going in all the directions I need. The other thing that I noticed was that the measurements for each of the motors distance to the ESC, or actually the important part is the hole to ESC distance here. That all turned out to be about 8 millimeters for all 4 cases. So the distance from the edge of the hole here to the edge of the ESC here, when using the KISS ESCs, is about 8 millimeters, and that will allow these cowlings to fit properly. And you can see well, that's the wrong one, but you can see they drop in over the ESCs just fine. So the next thing I'm going to do is prepare each of the ESCs with the rest of the wires that we need to go through the other hole to the top side. So I'm just going to cut some lengths of wire. I'm going to make some rough estimations on how long they need to be to get to the PDB. So I'll just put the PDB in place temporarily and make some measurements and cut those wires to length. And one thing we will note when we're doing that is that we want the wires to clear these supports. So when the wires come through this hole, I want them to go through the front here. I think that'll be the cleanest way because the PDB is going to be sitting in there like this. The battery wire will be coming out the side, but if you look at this layout, it seems to me it'll be the cleanest to have the wires snaking in there. If they go around the back, then they have to go, I think, a little bit longer distance. Anyway, that's how I'm going to try it. That's how it was shown on the Anomaly Drones website in the pictures and on the forums. So I'm going to give it a shot like that. Oh my god, what a mess. No, not really. Okay, so here's what we've got. We've got each of our ESCs has wires on it now for the flight controller and power, and I've just snaked the wires through the holes, and in one case here I did put the cowling on so that you can see that what it looks like all buttoned up. So there's a lot of wires here, but you know, it's all clear where they go. And I did a little bit of measuring, and I found that for the power wires I made those each 5 inches long, and they look like they're going to need to be about 4 inches long, so I have a little extra there. And for the signal wires I made those even longer, about 6 inches each, because the way the KISS flight controller goes in, sometimes the wires have to go kind of all the way from the front left to the right rear. So, you know, in that case, they need to be a little bit longer, so I just made everything 6 inches so I have plenty of wire to work with, and I'll trim them as I go along. So one of the nice things here about this design is, as you notice, this is all wired up and the cowling is not on there. The cowling just sits right on there, and we don't have to worry about wires passing through the cowling. So if you have problems with the ESC, you can take the cowling off, you can do whatever surgery you need to with replacing an ESC, and you put the cowling back on, and it's all very clean and easy. So next, I think I'll put the other cowlings on, and then I'll put the flight controller on here and start looking at getting some of these wires connected. Actually, even before I do the flight controller, I think I'll do the power wires first. So I'll just get these signal wires out of the way, and I'll snake all my power wires through here. And in order to do that, what I'm going to do is I'm going to put these little supports on. So the front of the machine is to your left here, and I'm going to put the supports in place because I said that I wanted to snake the wires kind of in the front of the supports. So let's see if I get these signal wires out of here, out of the way. I've got, just for now, get the power wire here. So these are going to go like this, with the power wires snaked behind, like that. Stick those guys in here. All the wires will run through here, but just for now I'm going to be doing the power wires first, so I'm going to snake those through there first. And since the wires pass through here like this, what I did is I also took a file to this piece and I made this edge a little bit rounded here and right here, because the wire is going to be kind of snaking around there and I don't want it to chafe on there and get damaged. So the next thing I'll do is get the PWB wired and for each ESC, and then after that I can get to the flight controller. Before I complete the PDB soldering, including the ESC leads, I just wanted to stop and show you guys real fast what I did here with the PDB. I covered the back with electrical tape because it's going to be sitting flat on the chassis here, and solder the battery leads in place, and the connector will come out to the right, so that will be the front of the machine. And I put the ProSight connector on there as well, the leads for that, and I decided to use aux2 for that. That'll be coming out the back and then wrapping around to the top of the transmitter. And I'll use the aux1 there to power the flight controller. Now, you will notice if you try to use a standard PDB on this frame that you'll have to file out the holes in the corners a little bit, because I believe this frame is cut to use the KISS flight controller, which is a 30mm spacing, I believe, and I think most are 30.5, so you end up with a little bit of a kind of a tight fit. And I think it's best to just use a file to clear out those holes and make them a little bit oval shaped so that they'll just slide right down onto the frame nicely. Hey folks, quick correction there. Don't use aux2. Aux2 is for use with a Pololu, which we're not using. And you really want to use aux1 or just connect your ProSight transmitter to your battery directly, because I connected it to aux2 and it didn't work. Okay folks, well I have my PDB mostly wired up now. As you can see, I've soldered all of the power wires for the ESCs. I've got my battery connector there, and I have the ProSight connector there. And I'm not going to do the flight controller plus and minus just yet because I don't want that in the way. But this would be a good time to do the smoke test, because we've got all of our ESCs hooked up, and so that's the first time when I like to kind of plug everything in and see if I get any magic smoke coming out. So let's hope that we don't. And I think I mentioned this in one of my previous videos, but this is the smoke tester. It's just a light bulb in series with power connectors for a battery. So what you can do then is you can plug this into your quad, and then when you plug a battery into it, the light bulb will light up if it encounters a short on this end. Let's see if we get any light from the light bulb. No light from the light bulb. That's good. Now enough power might not pass through to actually activate the ESC, so you don't hear them ringing. So we'll unplug the smoke tester and try it again without that. So this is a real test, right? Plug in the battery directly in and see if we hear the ESCs go. Yep. There we go. I don't see any smoke coming out anywhere, do you? Oh, one other tip I want to mention here. I put the power distribution board up above the frame when I did the soldering. In the final configuration, it's going to be sitting right on the chassis or on the carbon. But in this configuration, it draws less heat away from the soldering iron when you're trying to solder on there. These power distribution boards have thick copper in them, so they act as heat sinks when you're trying to solder, especially the negative terminals seem to suck the most heat out. So if you elevate it or just do it off the quadcopter, it makes it a little bit easier to solder and you don't need to use as much heat, which is good. Okay, so I now have all of the signal wires soldered up, and you saw in my fast forward footage of me kind of going through the process of figuring out the wire lengths, making sure everything's going to fit, mounting the flight controller upside down in some cases to solder the wires that go on the underside, and just sort of tinning and stripping and doing all the wiring. Now I did remove the receiver wires at one point just to make it a little bit easier to get some of the other wiring in place. I didn't really need to do that, but I had that receiver wire on there for a while and it was flexing back and forth a lot, and I was afraid that the solder joints were going to fatigue right there at the board, so I decided to desolder it, clip the wires. I just clipped them about 1/4 inch and resoldered them on. And I connected the receiver here, because at this point we've got everything hooked up and we can get the motors spinning and figure out which ones are going in the wrong direction. And once we figure that out, we'll pull the cowling off and solder the little jumpers in place as needed. So let's get the radio and the battery out and try that next.
Welcome to Tyrannus.
Alright, let's see if we can arm. Awesome. We have 4 motors spinning. Let's figure out which way they're going. Alright, number 4 is going in the right way. Number 3 is going in the right way. Number 2 is going in the right way. This is weird. Okay, number 1's going the wrong way. Wow, out of 4, we only got 1 going the wrong direction. I put little pieces of tape here and marked them because when I was wiring up the flight controller, I didn't want to forget what was what. I know it sounds simple, but just to have big labels on there makes things a little bit easier for me. It makes it kind of impossible to get it backwards, which I have done before. So we got really lucky here. We're going to take this one cowling off, and we can fix that little reverse problem on, let's check motor number 1. That's this guy. So now, if we look on the ESC, I think it actually says JP1 on it. It's that little guy right there. So we're just going to solder that guy real quick. Bridged. Let's do another test.
Welcome to Tyrannus.
Alright. Just checking. Yep. Alright, we're good to go. We're all spinning in the right direction. Alright, we've got our little camera mount. I just wanted to show you how easy it is to mount this camera. You don't actually have to remove the lens. You might think, oh, it doesn't fit through here, but it actually does because this material is flexible. So you can kind of just there you go. Get it aligned here and just tighten those screws. I don't think you have to make these super tight. For me, I'm tilting it up to the 30-degree position. Just making sure that sits in there nice. And that's it. And we'll just screw that on there. And there you have it. Okay, a couple things I learned here. I found it easier to mount the antenna with this rear part removed. I also just put a little piece of tape to hold this guy down. He wanted to pop out. That's why the tape is there. But I was trying to figure out a good way to coil up the antenna wires rather. And these little clips that are built in are genius. But I needed to fiddle with this a little bit to figure out how I was going to coil the wire up in there neatly and have it come out roughly where it needs to go for the antenna. And I think this is the solution I've come up with. Most of it coils coming out of the plastic antenna. It coils to the left and then down under the antenna and around. And the two wires, since one is going to the top here and one is going to the vertical antenna, they come out at different lengths, so you do need to fiddle around with it a little bit, but I'm going to try this and see how it works out. So now I can just slide this guy in. I'm holding the receiver up. Just slide this in here like that, and then the receiver will just kind of sit there. I don't know if it really needs anything more than that. Well, I think this will work. I slid the antenna mount back in place, and I hinged the top transmitter mount over, and I connected the RF connectors from the antennas underneath there. It was a little bit fiddly. You kind of have to do a few things at once. You have to connect the camera cable. You have to connect the connectors for the transmitter. You have to make sure you get the power cable. And then you have to make sure the receiver gets in there. And in my case, I also have a buzzer that I just kind of lifted up over the post, or put down over the post rather, and then lift it up here so when I push this down to meet it, it doesn't interfere. And so I haven't finished pushing this all the way down yet, but I put it in place just so I could check out to make sure that everything was going to fit, and make sure that especially those antenna wires. I always worry about those getting crunched or crimped or moved in a weird direction or not be supported, and I think everything's going to be fine as I push this down. The receiver ended up tucking in there very nicely, if you can see that down in there. The antenna wires, the receiver antenna wires, I just fed those up through the holes after I had this in place. And again, I've just got my little piece of tape to hold this piece of carbon down because it kept wanting to pop out. I think now I can just go ahead and push everything down into place as I make sure that nothing gets pinched. success. So I have the top mounting piece all the way down. It sits flush with the standoffs all the way around. I did pull I didn't catch it on video, but I did pull the receiver wires down through the bottom instead. And I ran the buzzer wire just through this little opening here. Frankly, I haven't figured out exactly how I'm going to keep that from flopping around. Maybe I don't care. So now I should be able to top the assembly with the top plate. Let's put it in the right orientation. Just fits into the slots in the carbon there. If I can find it. There we go. Now, a couple of things I want to mention. I need to put my battery strap in there and put some Velcro on the top. But also, I did use a pretty low profile stack up here for the flight controller. You can see I have, well, maybe you can't tell, but I have 6mm spacers in there with plastic nuts, and then I trimmed the standoffs, and the PDB is sitting right on the carbon. There's the little access for the ProSight transmitter, micro USB, and of course the KISS FC on the other side. All my wires are tucked in, nothing's binding, everything is good. And so we're getting really close here. I'm going to pull this top plate back off so that I can clean it, put some Velcro on it. I've got screws to go in, of course, and put a battery strap through it. Or maybe I'll use like a sort of rubbery material like you get on an Impulse RC Alien. Haven't decided yet, but that'll come up next, and then we're pretty much done. Oh, I gotta put my little antenna holders in. I took a couple of straws, like coffee stirrers, heated them with a little lighter, and bent them at I don't know, roughly 45. It's not perfect, but my plan is to stick them in there so they're sticking out at the 45-degree angle that they're supposed to be. I know you could probably just put them vertical and it'd probably work fine, but technically for antenna diversity you do want to have them at 45. So that's my plan. Okay, here it is, ready to rock. I did go back and put 4 screws in each motor with Loctite, and I used a washer there to give a little bit more surface area on this material, which is the flexible type. And I found that that gave me the right screw length as well. You don't want to go too far into the motor, especially on the side that has the wires, because you can actually put the screw right through the windings. So yeah, I ran out of screws, and I had to use a combination of stainless screws and regular screws, so it looks a little ugly, but it's the bottom, right? So who cares? I made sure all the fasteners were tight. I put a zip tie in the around the buzzer here, which kind of looks terrible when the rest of the machine looks so clean, but that's the best I could come up with. I didn't want to completely flapping around. I haven't found a better place for it. I may at some point take the top plate off and see if I can find a better place for the buzzer. But other than that, it's ready to go. The only other thing I noticed here is my little antennas are probably going to they're probably either going to fall out or move around or what. I'm not sure it will make that much difference in flight, but I might, as much as I'd like to have the 45-degree angle, I may just end up going to straight antennas and see how that works. Other than that, the machine is ready to go, and so stay tuned for the next video where I will do some flight footage of this thing. I had some fun with the last Anomaly Drones machine where I actually did some like slow-mo footage of it taking off and everything. Check out my channel for all that fun stuff. It was pretty cool, at least I thought so. And I'll probably do a repeat of that kind of thing, try to get some high-speed footage of it, slow it down. It looks pretty cool going through obstacles and stuff. And of course I'll report back and we'll see how the 6-inch props go. So stay tuned for the flight test. Thanks for watching, and please subscribe.